All right. All right, I'm ready for you guys. Let's go ahead and get moving through this, okay? Because we probably won't get to them all at this point. You need to tell me what you want to see. Page number, problem number. The 111 through 114, you can get rid of those. Those were on the last test. Okay? You need to make sure you also, in addition to what we do, know the cone and the ladder. Okay? Jordan, which one?
So we do number page 138, number 69.
Page 138. Alright. Okay, so we need to find the equation of the tangent line to the graph at the given point. We've got that y equals 2x cubed plus 1 squared at the point negative 1, 1. And we need equation of the tangent line. So what do I have to do to get the equation of the tangent line? Derivative gives us the slope. What rule are we going to need here? Chain rule. So we're going to take this 2, move it to the front. So 2 times 2x cubed plus 1 to the first. And then the inner function, what's the derivative of the inner function? 6x squared. And then I need to plug in a negative 1. So we've got 2. What's negative 1 cubed? Negative 1 times 2 is? Negative 2, let's see, 6, or negative 1 squared is? 1 times 6 is? 6. Negative 2 times 1 is? Sorry, negative 2 plus 1 is? Negative 1. So my slope ends up being? Negative 12. Okay, and then equation of tangent line, this point, this slope. So y minus my y value 1 equals negative 12, x minus negative 1, or plus 1. All right, what else?
Page 154.
Go ahead, 154.
Number 14.
14. Page 154, number 14. Alright, I think we had done this one or something similar in our notes. Find the rate of change of the distance between the origin and a point moving on the graph of sine. So sine we know looks like this, okay? Kind of keeps going. But what they're looking at is that triangle, okay? This point here would be x sine x, right? Because that's the function, is the y value. They give us that dx dt equals 2 centimeters per second. Find the rate of change of the distance. We get to leave it in terms of x and y. So this is x and this would be sine x. And they want the, what did it say? Distance between the origin and the moving point. So they're looking at this. I think I used a d on it. So our question mark is d dt. Okay? That's a centimeters per second. Can't you read that this morning? Jeez. Alright, so I'm going to use Pythagorean Theorem with what I have set up there. So I would say x squared plus sine x squared equals the distance squared. And then we're going to take the derivative of that implicitly. So it's with respect to time, what's the derivative of x squared? Dx dt, good. Plus, we're going to bring this into the front. So 2 sine x, the derivative of sine is what? Cosine x, and then the derivative of the x would be dx dt. Okay, equals, Hi. Alright, and then we've got 2d dt. Alright, and then the only other thing we would do is bring this guy to the other side. So d dt, and we're going to divide by the 2d. So, we can put dx dt in, right? So at the same time I'm going to put in dx dt. 2 plus 2 sine x cosine x times 2. The other thing we could do, CJ could just sit somewhere else. Alright. The other thing we can do is we could sub in for the d, because couldn't I solve this thing for d? Do the square root of it?
Yeah.
So I could have 4x plus 4 sine x cosine x over 2 times the square root of x squared plus sine squared x. That one's pretty ugly. I probably wouldn't guarantee that one on the test. Okay? I'd rather you be able to do the cone and the ladder. Okay? Does that make sense? This, the 2 was from here. The square root, I solved this thing here for d by taking the square root of both sides. Okay?
Oh, you went back to the original. Sure.
Huh? Yeah, I went back to the original equation and solved it for d. Because you can't, usually we leave it all in x's and y's, not in the d's. Okay? Alright, what else? 146, problem 9. Okay. So page 146, number 9. You had to implicitly derive x cubed minus xy plus y squared equals 4. Okay. Shh. We are going to do this with respect to x. So, the derivative of x cubed is what? 3x dx dx, right? Because we don't have time in this one. Alright, what rule's going on here? Product rule. So be careful because we've got a negative 1 hanging out. So we've got negative 1x, keep the first, derivative of the second is? Good. Plus, but it's plus a negative, right? So it's still minus. Keep the second, derivative of the first is? 1. What's wrong, David?
That's the wrong problem.
That's the wrong problem.
Just keep going.
Oh, I did number 5. Let's not do that. I'm not going to do the wrong number. Thank you for stopping me. Alright, so we've got, it was close. I had the x cubed part right. Y plus 2xy squared. This one's much worse. Okay, let's try that again. Alright, so we've got an x cubed. We already said it's 3x squared. Alright, I'm going to keep the negative 3 first with the x squared. Derivative of y would be dy dx. And then I'm still going to keep the negative 3, keep the second, derivative of the first is 2x, not squared, just 2x. Okay, so that was the derivative of this piece is here. I'll use a different color for the other piece. Alright, so then we're going to do product rule again. Keep the first, which is 2x, derivative of the second would be 2y dy dx, plus keep the second with the 2y squared, derivative of the first, dx dx, equals 12. Okay, I am going to move everything over to the right that's not a dy dx.
Are we keeping 12 and 12 is 0?
Oh, thank you. 12 should be 0. Okay, I just made the mistake that typically people make. Alright, so I'm going to move everything over. At the same time, I'm going to factor out a dy dx. So I'm going to do dy dx. I'm going to take that out. And we're left behind with 3x squared and 4xy. Does that make sense? I multiplied these guys together. Equals, and now I'm going to move everything that doesn't have a dy dx to the other side. So I'm moving the negative 3x squared over. I'm moving the... To subtract it to the other side, it is. Alright. 3 times 2 is what? 6. So I'm going to add that 6xy over, and then we're going to subtract y squared. What do I have to do with this ugly mess here? Divide it to the other side. And then you may have to, depending upon if it's multiple choice or not, sometimes you have to pull out a negative or do something weird to simplify it. We saw some of those in the multiple choice on Friday, right? Or maybe it was BC, I can't remember. They all meld together. Oh, don't box your answer, right? You can bubble it, not box it. Alright, what else do you guys want to see? 137, 61. Maybe. Alright, so 137, number 61. So you had to evaluate the derivative at the given point. You had f of x equals 3 over x cubed minus 4. The point is -1, -3/5. Okay. So I'm going to take the derivative to begin with. Actually, I'm not going to take the derivative yet. Let's get this thing upstairs, because I don't want to do a quotient rule if I don't have to. I'm going to bring this upstairs by making the exponent -1. So x cubed minus 4 to the negative first. Alright, now let's do the derivative. I'm going to take this and bring it to the front, so I get what? X cubed minus 4 to the... You got to subtract 1, so -2. And then the chain rule gives me what? 3x squared. I would, before I plug in, move this thing back downstairs so it's in the right place. -3 times 3 is -9x squared, and then bring this whole thing downstairs with a squared on it. Then what are we going to plug in? A -1. And the good news is I just have to plug the value in. I don't have to do anything with it. What's -1 squared? 1. -1 cubed is -1 minus 4 squared. So I've got -9. What's -1 minus 4? Squared, which is 25. Oh, don't box it.
How do you say the negative square?
It's the -2 power.
I said it right. It just sounds weird.
Yeah, but that's what it is. Alright, what else? Yeah. Yes. So you guys are going to be 5 to 5:45. You guys are welcome to stay, and I can open the computer lab, but then I have to have BC do the last. I'm doing an hour and a half, so you guys get the first half, they get the second half. They have a test tomorrow, too. Please make sure your parents are here by 6:30, though, because I'm going to need to run home and feed the baby. Yeah.
Is the compound volume or is it going to be height?
I'm not telling.
Hey, Miss Ballard.
It'll be one or the other. So,
Miss Ballard,
yes.
are you gonna do the recording?
If it goes again, yeah. If it's on a day I can make it, absolutely.
It's definitely gonna go again. I don't know if you can make it on day. I say you're doing it on Halloween, or we're just like,
No, we're doing it in March, is what she said. Okay, what else do you guys want to do?
how do you postpone something for 17 months? I know it's not. It's January.
Alright, what else do you guys want to do? Shh. You tell me.
No, it's still gonna be a problem.
155, number 24. Okay. Going to 155, number 24. Okay, so this is the cone. Alright. So we've got a conical tank. Point down. 10 feet across the top and 12 feet deep, which means our radius is only 5, 12 feet deep. Okay. Water is flowing into the tank at a rate of 10 feet cubed per minute. What's feet cubed relate to? Volume. So that's dV dt. Okay. Find the rate of change of the depth of the water when the water is 8 feet deep. So the height equals 8. Okay? And remember, there's a second little triangle in here that's a radius and a height triangle. Alright, so I'm going to start with my volume formula, which hopefully some of you wrote on a poster somewhere.
1/3
1/3.
pi r squared h.
Okay, good. So then we got to take the derivative of that. So dV dt, and I'm switching my 1/3 to pi over 3. Alright, I keep the first, which is r squared. Derivative of the second with respect to time is dh dt. Plus, we keep the pi over 3. We're going to keep the second, the h. The derivative of the r is what? dr dt. Good. Alright, so let's start plugging in what we know. What's the dV dt? 10. What's the radius? Oh, at that moment we don't know yet, do we? We have to do this thing, right? Actually, I was doing r over 5 equals or h over 12, right? I'll get the door. So it should be that so far. When you cross multiply.
It's 12. No, but that's R in G, I think. Yeah.
It's 12R equals 5H. And then R equals 5/12 H. So at that moment, what can I plug in for the H? 8. So 5/12 times 8. Let's see. 4 goes into both of these. 4 goes into 8. 2 times and into 12. 3 times. So it looks like 10/3 is your radius. It's not pretty. But that's okay. We can deal with that. Alright. dH dt, we don't know. That's what we're solving for. Alright. Pi over 3. The height at that moment we said was 8. Twice the radius we said was 10/3. And we need to find dr dt, which comes from this guy right here. We have to take its derivative. So 5/12 dH dt. So I plug that in. I'm going to change colors while you're catching up. I did that so I can plug in for dr dt. Okay? Alright, so let's talk about simplifying here. Doesn't 4 go into both 12 and 8? Into 8 twice and into 12. I did that on purpose because of what we have here. What is 10 squared? 100. What's 3 squared? 9 times 3 is 27 pi dH dt. Okay? Now check this out. 3 times 3 times 3 in the denominator is... It's nice how that came out like that. Okay? Alright, and then we've got 2 times 2 is... 4 times 5 is... 20 times 10 is... 200 pi dH dt. What's 100 plus 200? 300 over 27 pi dH dt. Okay, I have to get this to the other side, which means I need to flip the reciprocal. So I'm going to multiply by 27 over 300 pi. That's a 300. I flip the reciprocal. Alright, so 10 goes into 300 30 times, and what does 27 over 30 reduce to? 9 over 10. Notice the pi is in the denominator. Don't box it. Highlight it. Okay? And it would be labeled as feet per minute, right? Nope, feet, because it's height. Feet cubed as if it was the volume. Alright? But you need to be careful because it could be the volume on the test. Alright? This one was the height. It could be the volume. Alright. What else do you guys want to talk about? I don't know what the order is because I don't have it in front of me.
Is there a ladder one?
I don't think I had a ladder on there. The ladder was just part of the what we've been doing. So make sure you know it. There's one on the whatchamacallit. On the there all those the ladder A and B problems. You can practice those. Take a picture of my work before you leave. Okay. I think there's also a video that has the ladder in it. Yeah, make sure you watch that. All right, you guys, what else? I think we've done all the harder ones off the back few pages, right? The other one is basically, instead of plugging in for dV dt, you're going to plug in for dH dt. And so it all solves on the right side and you don't have to divide anything. Okay? All right, what else, guys? Give me a page number, problem number. 154, which one? 16. Okay, page 154, number 16. Shh. Let the area of the circle... Shh. There's no 16. 15, not 16. Shh. The radius of the circle is increasing at a rate. So radius increasing would be dr dt. At a rate of 3 centimeters per minute. find the rates of change of the area. So we're looking for dA dt. It's our big question mark. When r equals 6 and r equals 24. So they want it when r equals 6 was part A, and when r equals 24 is part B. Okay, so first of all, what's the formula for area of a circle? Yep. So we just need to take the derivative of that with respect to time. So what's the derivative of A? Good. The pi is going to stay. We bring the 2 in front. So 2 pi r. What's the derivative? What else do I need to write? dr dt. And we're going to go ahead and plug in. So A said we're plugging in a 6. B said we're plugging in a 24. So dA dt equals 2 pi. What's the radius? 6. And the dr dt? 3. So 18 times 2, 36 pi. And it's still being, oh, dA, centimeters squared per minute. You want a lot of those? Okay. And then 2 pi times the radius is 24. The rate is still 3. Well, you guys have calculators, don't you? 48 times 3, whatever that is. Centimeters squared per minute. Is it 72? 144. Okay. Also, just so you know, I think I mentioned it on Friday, the cone problem and the ladder problem are going to be worth more points than the other problems on the test. So you don't just skip them.
How much?
Probably be double.
Okay.
Okay.
What if I get like half of it?
It would, there'll be partial credit on it. Okay. So I'm not saying they're gonna. It's not gonna be like a multiple choice where it's all or nothing. Okay. There'll be partial credit on those. Okay. I don't know. I haven't decided yet. We haven't looked. Okay. What? I'll know. I may know more tonight. I don't know. We'll see if I have it written by tonight. Okay. What else do we need to talk about? You tell me, you guys. Still have quite a bit of time that we could get a few more done.
137 problem 25.
137, problem 25. I think 137 is the only ones that we haven't done, right?
Yeah.
Okay, that's 25. Okay, so 25 says that we've got y equals x square root of 1 minus x squared. So it looks like I've got a product rule and a chain rule going on there. Okay, so I'm going to rewrite it before I do anything else. Okay, so I see the product rule, and then this is the chain rule in here when I take that derivative. So, keep the first. Derivative of the second says that I'm going to do this and move it to the front. So 1/2 1 minus x squared to the negative 1/2. And then the derivative of this is what? Negative 2x plus. Keep the second, which is 1 minus x squared to the 1/2 power. What's the derivative of the first? Just 1. So I'm just going to leave it, right? There is no need to simplify it from there if you don't want to, okay? We could, right? I could take and do, let's see, this 2 and that 2 would cancel. I would be left with negative x squared over the square root of 1 minus x squared, because that comes downstairs, plus the square root of 1 minus x squared. I would take both of those answers. Okay, but if you simplify and you simplify wrong, I have to take points off. Okay, so don't simplify. All right, what else? What's wrong, Caesar?
Okay, why couldn't you just do the chain rule?
Because we had a multiplication in there. I did do the chain rule when I took the derivative of that chunk. We couldn't just do the chain rule because we have x times that. All right? Okay, what else do you guys want to talk about?
Page 137.
Uh-huh.
Number
55. Okay, 137, number 55. We have f of t equals 3 secant squared of pi t minus 1. Alright, before I do that, I'm going to rewrite it as 3 secant of pi t minus 1 squared. So the squared is the outermost function. This is like a peanut butter M&M. Okay? So there's a you got to do the chain rule twice. Alright, so we're going to take this 2, bring it where? To the front. So 3 times 2 is 6. And we leave everything else the way it looks. Pi t minus 1. Now we have to take the derivative of secant. What's the derivative of secant? Secant tangent of whatever the mass is that's on the inside. T minus 1, pi t minus 1. Alright, and then we got to take the derivative of the inner function, which ends up being what? What's the derivative of this inside piece? What's the derivative of pi t? Pi. Pi is a number, right? Notice I just snuck it in front. Could I rewrite it? Say it's multiple choice. They're probably going to do this. Secant squared pi t minus 1 times tangent of pi t minus 1. If it's not a multiple choice, you do not need to simplify it. But if it is, you got to keep going. Make sure you get one of those answers. Okay? All right, what else? Are there any others you guys want to talk about that we haven't done yet?
Number 61 on the same page.
61, same page. We did that one already.
46.
46 on the same page? Alright, so page 137, number 46 says that we've got y equals cosine of 1 minus 2x squared. Okay. So, notice the squared is on the parentheses, not on the cosine. So the cosine is the outermost function this time. So y prime equals, what's the derivative of cosine? Negative sine of whatever the mess is. 1 minus 2x squared. Okay. Then I've got to do the chain rule piece that is just this chunk right here. Okay. So I'm going to bring the 2 into the front. So 2 times 1 minus 2x to the first. Then we have to do the chunk that is inside the parentheses. So again, peanut butter M&M. When in the inside of the parentheses, what do we end up with? Just negative 2. And again, you do not need to simplify it. We could. If it was simplified, we'd have negative times a negative would be positive. And it's going to be 2 times 2 is 4. I'd probably move this algebraic piece up front and leave the trig in the back. All right, what else? Is that it?
Number 83 on page 138.
138, number 83. Find the second derivative of the function. So you have f of x equals 2 times x squared minus 1 cubed. And I've got to go to second derivative. So the cube is going to come out front. So 2 times 3 is what? 6 times the middle to the squared. And then what's the derivative of the inside? 2x. I would probably simplify this before I try to go to second derivative. So 6 times 2x is 12x times x squared minus 1 squared. I'm going to have to use a product rule and a chain rule. Okay? There is a way around it, however. If you don't want to try to do that, you could FOIL this back piece and distribute this in. That's another valid way of doing it. You're going to do just as much work, though. Okay? So, keep the first. Derivative of the second says I take this and bring it to the front. So 2 times x squared minus 1 to the first. And then the derivative of the inside is 2x. Plus, keep the second, which is the x squared minus 1 squared. Derivative of the 12x is 12. We could simplify it. Let's see. 4 times 1248x, is that right? Times x squared minus 1 plus 12x squared minus 1 squared. What's wrong? 12 times 2 times 2.
Oh, you multiply.
Yeah, I just multiplied. It's really bad when the easy stuff is what we are having, what we're confused about, right? We can do the calculus.
You can't do that.
It's usually the arithmetic and the algebra that kill us.
You know what? Forget it out.
Yeah. Alright, what else? Are there any others you guys want to talk about that we haven't done yet?
Seven.
7?
On page
137, number 7. Oops, I'm out of space again. Let's go to discard. Okay. So page 137, number 7. Okay, so that one is, you're going to want this one on the test, right? Because it's a pretty simple chain rule. So I'm going to take this and bring it to the front. 2x minus 7 squared, and then the derivative of the inside is just 2. So you'd have 6 times 2x minus 7 squared. What else? Are there any others that we haven't done yet? Or did we do them all?
I think we've done number
29, I don't think we have either. 137, number 29, where you've got the quotient rule inside the chain rule. So f of x, this is one you would definitely not simplify. It's not f of x, it's g of x. G of x equals x plus 5 over x squared plus 2 squared. And I know we did this one when we went over homework, or we did it in the notes somewhere. Alright, so the outermost function is the squared. I'm going to bring that to the front, so 2 times x plus 5 over x squared plus 2 to the first. Then I've got to do the derivative of the inside, which is a quotient rule. So low d high, what's your low? Good. Derivative of high is going to be 1. Minus the high, which is x plus 5, and the derivative of the low is what? 2x all over the low squared. True. The hard thing is you have to do the quotient rule in the right order. The product rule we do not have to do in the right order because this is a minus and the product is a plus. But yeah, it does have similarities. Alright, are there any others that we need to talk about?
Oh, so we just leave it like that?
Just leave it like that. Do not I wouldn't even try to simplify that for a multiple choice. Alright, are there any others? 46, so it's same page? We did it already.
46, yeah, we just listed.
Are there any others we haven't done? 10 on that page?
No, we just listed.
Okay, so 10 on that page. So 137, number 10. And we have f of t equals 9t plus 2 to the 2/3 power. Alright, so again, my outermost function is 2/3. So I'm going to bring that to the front. 9t plus 2. I'm going to subtract 1, which would be 3 over 3. So it would be what power? Negative 1/3. And then we got to do the inside function, which is going to be what? 9. So let's pretend it was multiple choice, because this would be a good one multiple choice since it's a simpler question. 3 goes into 9 how many times? 3. 2 times 3 would be 6. And then this guy's not happy where he's at, so we move him downstairs. Likely they would leave it, unless it's a squared. I'm doing my stuff backwards. Unless it's a squared, they tend to leave the fractional exponent. So it's 9t plus 2. Alright, are there any others, or did we get them all? I think we did, yeah, we did 46. I've been asked like 3 times now. 23? Okay. So page 137, number 23. We had f of x, so you're going to do a product and a chain, equals x squared times x minus 2 to the 4th power. Alright. we've got a product rule with a chain rule embedded in it. Well, sort of. The chain rule's derivative is 1, so it's not that bad. It's more of a product rule problem. Alright, so I keep the first, and then I take the derivative of the second. So where's the 4 going to end up? In the front. So 4 times x minus 2 to the third. And then what's the derivative of the inside? 1. But I still got to check that, right? You can't just not do it. Alright, and then I'm going to keep the second. And the derivative of the first is what? 2x. I'd probably leave it like that. They could do this weird thing. Let me show you one weird thing, just in case we miss on a multiple choice answer. I've tried to take them all out of the tests in the past. Sometimes test generators and test writers like to pull out a greatest common factor at this point. I don't know why they do that, but it's an ugly greatest common factor. So watch this. We have an x, right, in common. We've got the 2 in common, and then see how we have this thing here? They can pull that out. So watch what happens. So they're going to take out, if this was multiple choice, they could take out 2x times x minus 2 cubed. So in this term, then I'm left behind with 2x. Does that make sense? I've got 2x that I pulled out, and then I pulled that whole cubed thing out. Here, I already pulled out the 2x. I pulled out 3 of these, so there is 1 left behind. There's an x minus 2 left behind. Like I said, I've tried to pull these out because they're just nasty. And then what's 2x plus 2 or plus x? 3x. They love to do this. I don't know what it is, why they like to factor after they've done the problem, but so just be aware that that exists. So if you're not finding your multiple choice answer, it's possible they did something weird like that. It's a weird factor out. You're going to see it more next year than you will this year. Okay? All right. I think that was it. I will be here from 5 to 5:45 tonight. You're welcome to stay till 6:30, but I'm going to kick you into the computer lab. Okay? If you guys want to do a little study group in there, that's fine.